Okay, so a pay rise of 2.5% means that you'll want 102.5% of the original salary. So to work that out, then you do the 34,600 times by 1.025. If you type that in on your calculator, you'll get a final answer of 35,465. So that's the answer to the first question. If you don't like doing it that way, you can just find 2.5% and then add it on. So you could do 34,600 divided by 100 times it by 2.5, and when you do that you get 865, and then you just add that on then to the 34,600, and that'll get you the same answer then of 35,465. Okay, so here's some information about a group of 40 teenagers. There are 4 more boys than girls. So if I say that girls are X, then that means that boys are X plus 4. You know then that there are 40 of them in total. So X plus 4 has to equal 40. So you get a little equation. So 2x plus 4 is 40. Subtract 4 from both sides and we will get 2x to be 36. Divide both sides through by 2 and we get x to be 18. So there are 18 girls in total, and then that means that there has to be 22 boys in total. So if you're told 1/3 of the girls are vegetarians, so if there are 18 girls, 1/3 of that, when you divide it by 3, will give you 6. So there are 6 vegetarian girls, which means that there must be 12 that aren't vegetarians. So if there are 10 vegetarians in total, 6 are girls, that must mean 4 will be boys. If there are 12 non-vegetarian girls and 30 in total, then that must mean that there would be 18 that are boys. And if you just do a little check, the 4 plus the 18 does give you the 22. Okay, so question 3 involves using BIDMAS to work out the answer to this. So we want to find the value of V, and we're told that U is 3, A is minus 10 and T is 7. So we're going to fill that just into the formula given there. So we're saying V equals U, but we're told that U is 3, plus A, which is minus 10. I'm just going to put it in brackets. And then we've got T is 7, so I'm going to put that in brackets as well. Then by the laws of BODMAS or BIDMAS, we're going to do this minus 10 times 7 first of all. So I'm doing V equals 3. I've got a plus and a minus beside each other here. So plus and a minus cancel out together to give you a minus. So we're going to do then 10 times 7 to give us 70. So then you're working out 3 minus 70, and that turns out to be minus 67. Okay, so same thing again. This time we're given what V is, and we're going to work out what A is, and it's slightly more complicated numbers. But don't forget that you do have your calculator for this exam. So this time we're told that V is 7.3. So I'm filling in 7.3 equals U is 5.1. And then I'm doing plus A, which I don't know, I need to find that out, times T. So I've got A and then in brackets 5. Just going to tidy that up a little bit because we wouldn't write that last term there as A and then in brackets 5. We would write that as 5A. So I've got 7.3 is 5.1 plus 5A. Okay, so you have an equation here to solve. So first thing you want to do is get rid of that 5.1. So we're going to take that away from both sides. So if I minus 5.1 from both sides, then I end up with 2.2 equals 5A. And then I'm going to divide both sides through by 5, and I will get A then to come out to be 0.44 for that answer. Okay, so some angles here then. We want to work out the value of angle A. And if you look, these are on a straight line here. So angles in a straight line add up to 180. So to find out what A is, then we do 180, take away 136, and A turns out to be 44 degrees. Then we want to find angle B, and if you have a look, they're corresponding angles. So if you look, there is the F shape going on here, so A and B are the same, so that means that B is also 44 degrees. And finally then choose the correct word from the list, so it is the corresponding, so you just write that then in the space below there. Julia is paid to go contract for mobile phone, so voice calls are 7p per minute and texts are 10p each. So you're told, first of all, in August Julia paid £15. She made 120 minutes of voice calls. How many texts? So you want to find, first of all, the total cost of those voice calls. So each minute is worth, cost Julia 7p. So if she's done 120 minutes, then you're going to do 120 times 7, and you get 840 pence. Okay. Then, you know, if she's paid £15, if we just work in pence for this minute and time, then that's the same as 1,500 pence. So to find out the amount of money that came from her text, then we're doing 1,500 take away 840, and we see then that that is 660 pence that come from the text. If each text is 10p each, then in order to find out the amount of text, you're just going to divide that by 10. So you'll find then that in the month of August she sent 66 texts. Okay, in September now, so we're changing months, there were 140 minutes of voice calls, and she sent twice the number of texts that she sent in August. So you want to find her bill this time. So there was 140 minutes of voice calls, and you're going to do 140 times that by 7, and you will get 980 pence. Or because we're answering in pounds, the answer gives the pounds as units, so that's £9.80. So she sent twice the number of text as she did in August, then that will be 66 times that by 2, so that's 132 texts she sent in September. And if they are worth 10p each, then that cost her 1,320 pence, or £13.20. So to find her total bill, then you're just going to add together the £9.80 and the £13.20. When you do that, you'll see that your bill came to £23. Alright, question 6. There are a couple of ways of doing it. It's all about splitting up the shape. The fact that they're telling you the shape is symmetrical means that you could just split it straight down the middle vertically and work out the area of two trapeziums and then multiply it by 2. The easiest way to do this probably is just to go for a split here, just to split it into a rectangle and a triangle. So if you do that, then you want to find the area of the rectangle, so that's the length times the breadth, so that would just be 14 times 11. And if you wanted to find the area of a triangle, so area of a triangle then is a half times the base times the height. So that would be a half times the base, looks like a third, a half times the base, which is 14, times the height. Well, if you know that from here to here is 11, and you know that from here to here is 13, then that means that the height of the triangle has to be 2 centimetres. So you're going to do a half times 14 times 2. Okay, so when you work that out, then 14 times 11 is 154, and then a half times 14 times 2 is just 14. So to get your area of your shape, then you're doing 154 plus 14, so the answer turns out to be 168 centimetres squared. Right, so expanding these brackets, then you want to multiply everything inside that bracket by the 6 on the outside. So you would do 6 times 3x and then 6 times minus 2. So 6 times 3x is 18x. 6 times minus 2 is minus 12. So you get 18x minus 12. Similarly with part B, so expanding that first bracket then, you're going to get 8x plus 4. And then you're going to expand the second bracket, so you'll get minus 3 times x is minus 3x. Then you just need to be really careful here. You're doing minus 3 times minus 4. So when you do a minus times a minus, that gets you a plus. And then 3 times 4 is 12. Just be careful there not to leave that as a minus. Then finally you need to simplify it up. So if we gather the x terms in, so you've got 8x minus 3x, that gives you 5x. And then you've got 4 plus 12, so that's plus 16. Question 8 is about angles inside the hexagon. So 8a part 1, show clearly why angle A is 60 degrees. So you have to mathematically state why it is 60 degrees. So if you just look at the diagram then, you have here a point at the centre of the hexagon. You know that angles around the point have to add up to give you 360 degrees. And if you look, these have been split into 6 equal triangles. So you say angles at a point add to 360. So in order to find A then, because there are 6 identical triangles, A is going to be 360 divided by 6. And that gets you the 60 degrees that you need. Right, some of the interior angles of the hexagon then. Now, there is a formula for that. So interior angles is 180 upon n minus 2. And n is just the number of the sides of the shape, okay? So I'll write that over here. So n is the number of sides the shape has. So hexagon, 6 sides, so you're going to do 180 upon 6 minus 2. So that's 180 times that by 4 and you get 720. So the interior angles are 720. And just remember that an interior angle is a whole angle on the inside of that shape. Other way would have been to do it would be to say that you've got an equilateral triangle. So where that A is, you've got an equilateral triangle here. So you know that this has to be 60 degrees down here. And then similarly this one. So that's 60 degrees and then that's 60 degrees. So you can work out that each one is 120. Times that by 6 and you will get 720. P, Q, R and S are 4 vertices of a regular polygon. Regular means that every side is the same length. So each exterior angle is 18 degrees. Work out the number of sides of the polygon. So you know the rule that all exterior angles have to add to give you 360 degrees. So if each exterior angle is going to be 18, I mean, so there's going to be 18, and there's going to be 18, and so on the whole way around of these. There are going to be n of them around the shape. So in order to work out what n is, you're just going to do 360 divided by 18, and that will tell you how many of them there will be in order for each exterior angle to add up to 360, and the answer then is 20. So there are 20 exterior angles, which means that there are 20 sides to that shape. Okay, question 9 then. Two numbers A and B are less than 15. The least common multiple of A and B is 24. Give one possible pairs for the two numbers A and B. Now there are there's more than one right answer to this question. So basically you want to think of your numbers between 1 and 15. 1 and 14 because it has to be less than 15, and you want to consider their lowest common multiple. Now the easiest way to do this is to think of two numbers that multiply together to give you 24, and then you see if they have a multiple in common before that. So if you think of if you think of 2 and 12, their lowest common multiple will be 12, so they're not going to help you. If you think of 3 and 8, their lowest common multiple is 24, and they are less than 15, so that's an acceptable answer. Other answers that would have worked would have been 8 and 12, or 6 and 8. So two numbers x and y are each between 10 and 20. the highest common factor of x and y is 3. Give one possible pair of numbers between x and y. If they have to have a highest common factor of 3, then that means they have to be divisible by 3. So the first thing you want to do is consider all the numbers that are divisible by 3, so between 10 and 20. So you've got 12, 15 and 18, so they're the 3 numbers that you're considering. So you want to pick a pair of these so that their highest common factor, so the biggest number that will divide into both of the numbers, is 3. So you could have 12 and 15. The highest number that will divide into both of those will be 3. You could also have 15 and 18, but you can't have 12 and 18 because if you have 12 and 18, 6 will divide into both of those. So the highest common factor would no longer be 3. Homemade 4-sided spinner is known to be biased. That's the key word to this question. So even though it has 4 possible numbers to land on, that doesn't mean that they're a quarter each. Okay. So table shows the probabilities of getting each score. So to get a score of 1, it's 1/10 and so on. What is the possibility of landing on a 1 or a 2? So you have 1/10 of landing on a 1, and there's a probability of 3/10 of landing on a 2. So in total then you have a probability of 4/10 or 2/5 if you simplify your fractions down of landing on a 1 or a 2. Spinner is spun 400 times. How many times would you expect it to land on a 3? Well, the probability that it'll land on a 3 is 7/20. So really you want to find 7/20ths of 400. So what you want to do is find 1/20th first of all. So we'll do 400, divide that by 20. That'll give us 1/20th, and that turns out to be 20. And then to find 7/20ths, you're just going to times that by 7. So you would expect it to land on a 3 then 140 times. Okay, we're going to solve this equation so that we have x is on both sides of this equation, so we want to try and get x onto one side. You want to pick the side with the biggest amount of x's, so in this case you want to get x's over to the left hand side. So to do that you want to remove the 2x from the right hand side. So remove the 2x, you're going to take it away from the right hand side, but whatever you do to one side you have to do to the other. So we have then on the left hand side 4x minus 1, and then that equals on the right hand side 4. So then this becomes a very basic equation. You need to get rid of the minus 1 on the left hand side, so we're going to add 1 to both sides, and we have 4x equals 5. Then we'll divide both sides through by 4, and you will get x to be 1 1/4 or 1.25. Either way is perfectly acceptable. Okay, I'm going to make this slightly more tricky, than we've got fractions involved this time. So to start off with, we're going to cross multiply. So basically we're going to multiply up by the 2 on the right hand side. So we're going to multiply both sides by 2. That'll get rid of that there and move it up to there. And then we're going to multiply both sides by 3, and that will move that. I'll get rid of it on the bottom line there, and it will become up there. So basically this is called cross multiplying. You can do that just across an equal sign. So when you do that, you have 2 and then in brackets 2y minus 5, and then that equals 3, and then in brackets 4y minus 1. Okay, so now we're going to multiply out the brackets. So we get 4y minus 10 equals 12y minus 3, and then this becomes similar problem to the one up above. So we want to get all the y's over to the right hand side this time because there are more y's on the right hand side. So to do that I'm going to take away 4y from both sides. So I have minus 10 equals 8y minus 3. Want to remove the minus 3, so I'm going to add 3 to both sides. So I get minus 7 equals 8y. And then finally I want to get y on its own, so I'm dividing both sides through by 8, and it's fine to just leave your answer then as minus 7/8. If you did want to leave it as a decimal, then it would be minus 0.875, and you could just do that by typing it into your calculator. company reduces the prices of its new cars by 8% after the reduction. A car costs $24,288. What was the price of this car before the reduction? Okay, so you're given information about what's happened after the reduction has occurred. You want to find out what happened before it occurred. So this is reverse percentages. So basically, if the cars have been reduced in price by 8%, then they are 92% of their original price. So 100 minus 8 is 92. So 92% of the original price is equivalent then to £24,288. If you want to find the price before the reduction, you want to find 100% of the price. Okay, so to do that, if you find 1%, you can then multiply it by 100. So if I know 92% and I want to find 1%, I'm going to divide by 92. Whatever I do to one side, I'm going to do exactly the same to the other. So 24,288 divided by 92 turns out to be £264. So then if I know 1% is 264, to get 100%, I times both sides then by 100, and I will get that the price before the reduction is £26,400. Right, moving on then to a bit of standard form. Remember, when you're doing standard form, you need to have a number between 1 and 10, you need to have times 10, and you need to have a power. Okay, so you want to move your decimal point somewhere in this number so that you have a number between 1 and 10, and that number in this case will turn out to be 4.75. Okay, then we're going to have our times 10. This is a very, very small number, so the power will be negative, and then you want to find how many places your decimal point is going to move to get you from where you started to where you want to be. So we're moving 1, 2, 3, 4, 5, 6, 7 places. So it's 4.75 times 10 to the minus 7. Okay. Right, 13b. Obviously, this is a calculator exam, so you can just put this straight into your calculator. I'm going to do it out long, just so you have two ways of checking. So it's better to do this out the way I'm doing it now, and then check your answers a bit later on. Okay, so we are going to do 2.4 times 10 to the power of 9 plus 1.7 times 10 to the power of 8. So first thing we're going to do is just write these as long numbers first of all, so just as ordinary numbers. So you've got 2.4 times 10 to the power of 9. So I've got 2.4. It's a big number and I'm moving it in 9 places. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm going to fill those gaps with zeros. So I have 2, 4, and then I have 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. Next one then, I've got 1.7, and that's times 10 to the power of 8. So 1, 2, 3, 4, 5, 6, 7, 8. So this time I've got 7 zeros. Just be careful then when you're adding these that you line them up correctly, that you line them up from the right hand side. So 1, 2, 3, 4, 5, 6, 7, and then you've got 1, 7 there. So when we add those up then you get 0, 0, 0, 0, 0, 0, 0, 7, 5, 2. And then the question asks you to put your answer in standard form, so you need to remember to write that back in. So the number between 1 and 10 is 2.57. You've got times 10, and that is to the power of 1, 2, 3, 4, 5, 6, 7, 8, 9. So just be careful that you don't just count the zeros and make that the power, actually figure out how many places that decimal point has been shifted. Question 14. The graph of y equals x squared minus x minus 3 is shown on the grid, so you have the graph drawn for you. Write down the value of y when x is 1.5. Okay, so you want to have a look at this grid. You want to find out when x is 1.5. So if you go to your x-axis and you go across to x be 1.5, so that's just here, you want to draw a line using a ruler, either up or down, it doesn't matter, in any direction until you hit that curve that has been drawn for you. So if you have a look here, if I draw this line going down, I'm hitting the curve here, and I just want to read off the y value that occurs at. So when you go across, then you should be able to read off what that y value is now. Because of this not being an exact answer, they will accept more than one answer for that. So they will accept anywhere between minus 2.1 and minus 2.3. In this case mine is minus 2.2, but it'll just be whatever answer you read off the graph. Similarly then, they're asking you to write down the values, and that's the key thing, the fact that they're saying values here, so there's more than one answer, of x when y is minus 1. So if you go back up then to the graph, this time they're telling you y is minus 1. So if you go then to the y-axis and you go down to minus 1, and you draw a line in either direction until you hit the graph. So you can see there's one there, and there's one over here. And then if you just read up to the y values, what they are. So you can see then y is minus 1 and y is 2, and because they're exact values, they are the answers that they'll be looking for. So sorry, I said y is minus 1 and y was minus 2, I meant x. So x is 2 or x is minus 1. Okay, question 15. On the grid, draw lines to find the region satisfied by the three inequalities. So if you look here, all these inequalities have equal to lines, so whenever you draw them onto your graph, they are all going to be solid lines. Okay, so you don't need any dashed lines in this case, they're all solid lines. So that first one is probably the easiest one. So to do these, change the inequality sign to an equal sign, plot the line, and then go back and think about shading the correct region. So if we look at that first one, we want to plot the line y1. So if I'm plotting the line, I'm doing y equals 1. So if you go to your y-axis, you go to 1, and you're going to use a ruler then to draw a solid line at y equals 1. Yours is going to be much straighter than mine. You want y to be greater than or equal to 1. So if you consider the graph, then if you pick any point above that, y is going to be greater than 1. So the bit of the graph that you aren't interested in is where y is less than 1. So that's a bit under the line. I'm just going to shade that out to show that I'm not interested in it. Right, back up to the top then here. The next one then is y equals x plus 1. Okay, so this is a straight line equation. In order to draw this, you're going to need a table of values. So I'm just going to draw a little table of values over to the side here. So I've got x and y. Pick any three x points that you want. I'm going to pick 0, 1 and 2. And I'm going to fill those values for x into the equation to work out the values for y. So when x is 0, I'm doing y equals 0 plus 1, which is 1. When x is 1, 1 plus 1 gives me 2. And when x is 2, 2 plus 1 gives me 3. So there are the points I want to plot. So I want to plot 0, 1. Then I want to plot 1, 2. Then I want to plot 2, 3. And then again with a ruler, and we're doing a solid line, you're going to join up those points, and then you're going to extend the line just a little bit further. I'm just going to rub out that line that I've just drawn. It's very wonky. So you're going to join up those points, and then you're going to extend that line the entire way across the graph. Okay, so to decide which region then needs to be shaded, you pick any point at all on that graph. Now the best point to pick is probably the origin. Okay, so you pick the point 0, 0, and you're going to test it in your inequality. So if I have y is less than or equal to x plus 1, and I fill in the point 0, 0, okay, so if I fill that in, then I have 0 is less than or equal to 0 plus 1. So I'm saying 0 is less than or equal to 1. And that's true. Okay, so that means that origin is lying in the part of the graph that you're interested in. So the other side of the line then you're not interested in, and you can shade it out. Okay, Finally then, the last equation that you're interested in, changing the equal sign to an inequality sign. Sorry, the inequality sign to an equal sign. We have x plus y equals 5. I'm going to rearrange that just so that you're used to getting the equation y equals mx plus c. So if I take away x from both sides, then I have y equals minus x plus 5. So again, table of values, and 0, 1 and 2. So when x is 0, y is 5. When x is 1, you're doing minus 1 plus 5, so that gets you a 4. When x is 2, you're doing minus 2 plus 5, so that gets you a 3. So we're plotting the points 0, 5, then 1, 4, then 2, 3. Going to join those up with a solid line and extend it through the graph. Make sure you're using your ruler, please. And then you're going to decide which side of that line to shade through. So again, start off with that 0, 0. So I've got, my original inequality was x plus y is less than or equal to 5. We're using the point 0, 0. So I've got 0 plus 0 is less than or equal to 5. So I'm saying that 0 is less than or equal to 5. That's true. So the origin then, that point 0, 0, is on the side of the graph that you're interested in. So the other side of the line that you've just drawn, you can shade out. That leaves that little triangle there being the required region that you need, and you label that R then. Right, question 16. You want to solve this quadratic equation. You want to give your answer to 2 decimal places. That is your clue that this is your quadratic formula. Okay, it is given to you in your formula sheet at the front of the paper. So it is x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. So the number in front of the x squared is your a, so in this case a equals 2. The number in front of x is your b, so b equals 4. And then the constant at the end is your c, so c equals minus 7. So we're going to fill all these into the equation then to find out what x is. So x equals minus b, so minus 4, plus or minus the square root of b squared. I'm just going to keep everything in brackets. So 4 squared minus 4 times a, which is 2, and c, which is minus 7, just keeping everything in brackets. And that whole thing then is over 2 times 2. Okay, tidying this up then, so x equals minus 4 plus or minus the square root. 4 squared is 16. Just have to be careful here. Minus 4 times 2 times minus 7. This is the most common mistake that you'll make. Don't forget that you have got here a minus, and you're timesing that then by another minus. So you're going to end up with a plus here, and then 4 times 2 is 8, times that by 7, and you get 56. So the square root of 16 plus 56, that's all over 4. So you've got minus 4 plus or minus the square root of 72 over 4. Right, so this can be split up then. So you either have x is minus 4 plus the square root of 72 over 4, or x is minus 4 minus the square root of 72 all over 4. And when you type those into your calculator, then you will get x to be 1.12 to 2 decimal places, or minus 3.12 to 2 decimal places. Remember to give your answer to 2 decimal places at the very end. Work out the length x in this triangle. Give your answer to an appropriate degree of accuracy. That sentence is key in this question, so we'll come back to it at the end. But if you have right angle triangle here, so you have 2 options for right angle triangles. It's either Pythagoras or trigonometry. And because you're not considering any angles at all here, this is Pythagoras. So Pythagoras said that the square of the hypotenuse, so that's the side opposite the right angle, is equal to the other 2 sides squared and added together. So 32.6 squared equals 15.8 squared plus x squared. So typing that into your calculator then, 32.6 squared is 1062.76. That equals 15.8 squared, which is 249.64 plus x squared. You want to find what x squared is, so you're going to take away 249.64 from both sides, and when you do that then you get that x squared equals 813.12. Okay, so to find x then you're going to take the square root of that 813.12, and when you do that you will get x to be 28.515 and so on. Now, question says give your answer to an appropriate degree of accuracy, so there is a specific way that you should leave your answer, and the easiest way to do this is just to do it to the same degree of accuracy that they have in the question. So if you look in the question, they have done both of the numbers that they've given you to 1 decimal place, so that's the way that you should leave your answer as well. So if you write that then to 1 decimal place, then the answer is 28.5 centimetres. Right, in 17b then, you've still got a right angled triangle. Now we've got an angle into the equation here, so now this becomes trigonometry. So the most important thing about trigonometry is you label in your triangle correctly. So side opposite the right angle is your hypotenuse, and you label that as h. The side opposite the marked angle is called your opposite, and then the side beside your marked angle is called your adjacent. Okay. Then you have to decide whether or not you're using sine, cos, or tan. So easiest way to do that then is to use the word SOHCAHTOA. Okay, you're given information about the hypotenuse. You're given information about the adjacent. So you can see you know most information then about cos. So that's the trig function that you're going to use. So cos of the marked angle, so cos of y, equals your adjacent, which is 11, divided by your hypotenuse, which is 25. So if I do 11 divided by 25, I will get cos of y is 0.44. So to find y then you need to do the inverse cos of 0.44. So in your calculator then you're going to hit shift and then cos, and then type in 0.44, and you will get then just to 1 decimal place that the answer is 63.9 degrees. Question 18 gives you a cumulative frequency diagram showing the mass at birth of 80 babies born in a hospital in Europe. So the key thing here is that the total is 80. Okay, you always have to keep that in mind. Sometimes they'll draw the graph higher than the total, and it's always the total that they give you in the question that's important. So you're asked how many babies had a mass at birth of 3.5 kilograms or less. Now cumulative frequency gives you the amount of babies up to each particular mass. So when you go to your graph, if you read up at 3.5 kilograms, that will be the amount of babies up to 3.5 kilograms. So that will be the answer that you're interested in. So 3.5 kilograms, you're going to draw a line up, use a ruler until you hit the graph, and then across to read off the cumulative frequency, and you will see then that there were 50 babies with a mass of 3.5 kilograms or less. Next question then asks you for the median mass at birth. Okay, so median, as you should know, is your middle value. On a cumulative frequency graph you just get your total and you just divide it by 2. So if my total is 80, divide that by 2 and that's 40. So I'm going to be able to get my median mass by reading across the cumulative frequency of 40. So going to 40 on my cumulative frequency, and I'm going to read across. So again, draw in a line till you hit your graph, and then you're going to read down at the mass that is. And you do have to be precise here. So when you read across and down, the median mass should turn out to be 3.3 kilograms. Sorry, I'll just undo that. There we go. Yeah, so 3.3 kilograms. Now, if you flick forward, I'm not going to do it just now, just because of the slide that I'm on. Part C on the next page asks you for the interquartile range, okay? So just remember your interquartile range is your upper quartile, take away your lower quartile. So we're going to want to put these onto the graph. So I'll do lower quartile first of all. So lower quartile is a quarter of the way through, so I'm going to do 80 divided by 4, and that's 20. So I'm going to draw a line at 20, and I'm going to read down at what that is, and that will turn out to be 2.8. So my lower quartile then is 2.8. Upper quartile then is 3/4 of the way through, so the lower quartile, if 1/4 of the way through is 20, then 3/4 of the way through is 20 times 3, so that's at 60. So I need to go to 60, I need to go across, and I need to go down, and you will see then that your upper quartile then is 3.9. So if we go on then to the next, we can see that on the next page then our interquartile range is our upper quartile minus our lower quartile. Upper quartile we worked out to be 3.9, lower quartile was 2.8, so our interquartile range then is 1.1. Relating D, the box plot shows the masses at birth of 80 babies born in a hospital in Africa. So the cumulative frequency was for Europe, this is for Africa. Use the data to give two comparisons between the masses at birth of babies in Europe and in Africa. What I would do is just take a wee second just to write down all the information that you can get from the box plot. So your lower quartile, I'm going to call that Q1, so that's the first quartile, turns out to be 2.4. Your median, so that's your second quartile, is the line in the middle, and that turns out to be 2.9. Your upper quartile then is the line just at the end of the box, and that's 3.3. So for African then, your interquartile range is 3.3 take 2.4, and that then is 0.9. Okay, so now we have the same statistics that we had for Europe. We can start to make comparisons, and when they ask you questions about comparisons, really what they're interested in is you to compare the medians and you to compare the interquartile range. Median gives you an indication of, on average, what is happening with the mass of these babies. The interquartile range gives you, on average, the variation in results, so the spread in the results. So you can see it's worth 3 marks. So you're going to get 1 mark for talking about the median, 1 mark for talking about the interquartile range, and then you're going to get a mark for using some of the values that you've just worked out, okay? So I'm going to start off with the median. So in Africa, our median was 2.9, but we worked out in 18b that for Europe that was 3.3. So you can say then, on average, babies from Europe are of a larger mass than those from Africa, and then median equals 3.3 kilograms compared to 2.9 kilograms. Okay, and then you want to talk a bit about the interquartile range. So interquartile range for Africa was 0.9, and for Europe we worked out in part C that it was 1.1, so there's less variation in the weights in Africa than in Europe. Just put that down. So less variation in mass of babies from Africa than Europe, and then you just say IQR 0.9 kilograms compared to 1.1 kilograms. So I get 1 mark because I've talked about the median. So on average they're heavier. I get 1 mark for talking about their variation with their IQRs, and then I get 1 mark because I have specifically stated values. Question 19. On the parallelogram grid below, O to A is represented by the vector A and O to B is represented by the vector B. Point P is also shown. On the grid, mark the point Q such that O to Q is 2A plus B. So if you look, A is the same direction going to the right each time, so this little bit here is also A, this is A, and this is A, and so on. And then anything parallel to O to B will also be B. So we want to go 2A, so that's 1A, and then another A, and then we want to go 1B, so we're moving up this line, so that's a little B there. So that point there is the point Q, so we're going 2A across and then B up, so 2A plus B means that Q has to be in that position. I want to write down in terms of A and B the vector O to P. Well, if you have a look, to get from O to P there are many different routes you can take. I'm just going to have a little look at this route here. So I'm going to go from here the whole way across and then up to P. So the road I'm travelling, then I've got an A, an A, an A, and an A, so I have 4A, and then I am going up here, so I've got a B and another B, so I have plus 2B, so that's the vector then to get you from O to P, it's 4A plus 2B. N is the point such that O to N is 15A minus 7B. M is the point such that O to M is 45A minus 21B. Give a reason why the points O, N and M lie on a straight line. Okay, so if O, N and M lie on a straight line, that must mean that O to N and O to M are parallel. Okay, so for them to lie on the straight line, you have to state 2 things. They have to have a point in common, and they have to lie on a straight line. Okay, so because they are scalar multiples of each other, if you times O to N by 3, so basically O to M, you will get by doing 3 O to M. So they're scalar multiples of each other. Okay, so that means that they are parallel. So O to N and O to M are scalar multiples of each other. So they're parallel and have a common point because they both originate from O. So that implies they lie on a straight line. Right, write down the ratio of the lengths O to N and N to M. Okay, so if we look, we've got O to N and O to M, but we need to know what N to M is. Okay, so in order to get from N to M, we would need to go N to O and then O to M. Okay, so if you want to go N to O, you're going backwards, so it's going to be minus 15A, and then you're going to add on 45A, so that's going to be 30A. And then with the b's, so you're going to do minus 7b, so you'll have 7b minus 21b, so you're going to get minus 14b. So if you look then, that is 2 times O to n. So the ratio then is 1 to 2. Simon is training for a 10-kilometre race. He runs around the edge of a football pitch. Length of the pitch is 105 metres, measured to the nearest metre. So that must mean then that the lower bound could be 104.5 and the upper bound then would be 105.5. The width of the pitch 76 metres to the nearest metre, so we could have then a lower bound of 75.5 and an upper bound of 76.5. So how many times should Simon run around the pitch to run at least 10 kilometres? So you want to make sure he runs 10 kilometres. So you're trying to decide whether or not you want to work with your upper bounds or your lower bounds. So if you work with your upper bounds, you could be overestimating the amount that he's running. So you know, if you work with your upper bounds and you work out how many times he runs round 10 kilometres, that doesn't necessarily mean that he has run 10 kilometres, because it mightn't be as high as the upper bounds are implying them to be. So this time we need to work with our lower bounds. So we're looking at a rectangle and we're going to use our lower bounds for it. So we've got this football pitch here, and we're going to say that's 105.5 and we've got 75.5. So when he does one lap of it then, that's the perimeter. So we're working out the minimum perimeter of this football pitch. So the minimum perimeter is going to be 2 times 105.5 plus 2 times 75.5. So just adding up all the sides of the football pitch. And the minimum perimeter turns out to be 360 metres. So when he goes round the football pitch, once he travels 360 metres. So in a 10-kilometre race, that's 10,000 metres that he needs to travel. So if I do 10,000 divided by 360, I'm going to get 27.7. So in order to travel 10,000 kilometres, he has to go through 27.7 times. So if he's running around a pitch, you want to run around a whole number. If he runs around 27 times, then he hasn't ran enough. So then the final answer has to be 28 times. Cone has base radius 5 centimetres, vertical height 12 centimetres, surface area of the cone. So to work out the curved surface area of the cone, that's pi r L, where L is your slant height. Now if you look here, the slant height is this part of the cone. We don't have that. So first thing we're going to do is calculate the slant height of the cone. So we know that from here to here is 5 centimetres. We know that the height is 12 centimetres, but we want to find the slanted bit. Now you've got a right angle triangle going on, so I've just drawn a vertical line down that cone and taken that triangle out over the side there. So I can use Pythagoras then to help me work out the slant height. So x squared, so the hypotenuse squared, equals the other two sides squared and added. So when you do that, you will get x squared is 169, so x is 13. Okay, so the curved surface area, slant height is 13. So if I want to work out the curved surface area of this cone, I'm doing pi times the radius, which is 5, times the slant height, which is 13, and that gets me 65 pi. Okay. To get the total surface area, you have to remember that there is also a circle on the bottom of this cone. So the area of the circle then is pi r squared. So your total surface area is going to be your curved surface area, so that's 65 pi, plus pi r squared. So that extra circle, so you've got 65 pi, and then you're doing pi times 5 squared. So that's 65 pi plus 25 pi. If you add those together, you get 90 pi. And then you're just going to type that into your calculator. So you do 90 times pi into your calculator, and you will get the curved surface area to be 282.74. You can work out the 65 pi as a number and then fill it in, but just remember, don't round your answer in the middle of a question. Keep all of the decimal places in and round at the very, very end. Triangle number sequence starts 1, 3, 6, 10. So you can see that to get from one triangle number to the next, so to get from between 1 and 3 you're adding 2, and then 3 to 6 you're adding 3, 6 to 10 you're adding 4, so between 10 and the next one you want to add 5, so the next triangular number is 15. Okay, the nth triangular number is given by the formula a half n upon n plus 1. Work out the value for the 100th triangular number. So if you compare this part to this part, you will see that you're replacing n with 100. So we're going to do a half times 100, and then times 100 plus 1, so that's 101. So when you type that into your calculator, then you will get 5,050. Right, so a little bit of algebra here. When you add two consecutive triangular numbers, you always get a square number. For example, 6 plus 10 equals 16, which equals 4 squared. Prove this result algebraically. Okay, so they're not asking you to fill in all these different triangular numbers and just check that this is right. They're asking you to show it's right using algebra. So we know that a triangular number is given by that formula in part B. So one triangular number is given by a half n and then n plus 1. Okay, so that's your nth triangular number. So if you want to find the next triangular number, and we're going to add them together, so a half. If I'm looking for the next triangular number, then my n is now n plus 1. And instead of having n plus 1 in the second bracket, I'm then going to have n plus 2. Okay, so I've just added 1 to each n value. So that's what I'm looking at. Going to try and prove that this is a square number, so sometimes it's hard to see where to go, but usually when you have all these brackets, it should be intuitive for you to multiply out the brackets. So I have a half n squared plus a half n, and then over this side I've got a half, and I'll just keep it in brackets while I multiply these out. So you get n squared, then you get n and 2n, so that's 3n, and then 1 times 2 is 2. Don't forget there are many ways to multiply them out, but basically you want to multiply everything in the first bracket by everything in the second bracket and simplify it. Then just going to multiply out that second bit there, so I've got a half n squared plus a half n plus a half n squared, and then I'm just going to write that as 3 over 2n, and then 2 times a half is 1. Okay, tidying this up then, a half n squared and a half n squared is just n squared. A half n plus 3 over 2n is 4 over 2n. 4 over 2 is just 2, so you get a 2n, and then you've got a plus 1. Now, we're wanting to show that we have a square number. At this point here, you know, it's not making any sense at the minute, but you should be used to now, anytime you see a quadratic, trying to factorise it into your double brackets. So if you want to factorise this into double brackets then, so you've got your two brackets. It has to be an n in both of them. They have to multiply together at the end to give you a 1, so both these numbers have to be a 1, and both are plus. So it's n plus 1 times n plus 1, and if you look then that's just n plus 1 all squared, so you do end up with a squared number at the end, and that's you showing that when you add two consecutive triangle numbers together, you end up with the squared answer. Ernie plays 2 games of chess against a computer. It has 3 skill levels, low, intermediate and high. So it starts out intermediate level. Ernie knows that he will win 2 out of every 5 games at this, so the probability then of him winning a game of first game at intermediate level is 0.4. If Ernie wins the first game, it resets to the high skill level. So when it's on high skill level, chances of him winning then are half of that, so instead of it being 0.4 it's 0.2. And if he doesn't win, then it goes to a low skill level, and Ernie knows his chances of winning are doubled. So if it was originally 0.4, his chance of winning at low is 0.8. So what is the probability that Ernie wins both games? So if he wins his first game, probability of that is 0.4. And he wins his second game. So when he plays the second game, it's now going to be at high, okay, because when he wins the first game, it's set to the high skill level. So wins the first one's 0.4, and he wins the second, so we're multiplying that by 0.2. So the probability that he wins both games is 0.08. What is the probability that Ernie wins at least one of the 2 games that he plays? So when you hear the words at least one, that's the same as 1 minus the probability of none. Okay, so the probability that he doesn't win the first game and he doesn't win the second game. So the probability of at least one is 1 minus the probability of none. Okay, so the probability that he doesn't win either game. So that's going to be 1 minus probability that he loses the first game. If you go up and have a look, the probability that he wins the first game is 0.4, so the probability that he's going to lose that first game then is 0.6. Then if he loses the first game, then the computer is set to low, and the probability that he's going to win is 0.8. So the probability that he will lose that second game then is 0.2. And remember, he needs to lose the first game and the second game, so we're multiplying. So we're going to do here then 1 minus 0.6 times 0.2 is 0.12. So 1 minus 0.12 is 0.88. Okay, solve these simultaneous equations then. So you've got a linear and a quadratic. So in order to do this, you want to substitute this linear equation into the quadratic equation. So everywhere we see a y, we're going to replace it with x minus 3. So I have x squared plus y squared. So instead of having the y, I'm going to have x minus 3 all squared equals 17. Then I'm going to multiply out this double bracket and I'm going to tidy it up. Just remember that x minus 3 all squared is x minus 3 times x minus 3. And then remember that you have to multiply everything in that first bracket by everything in the second bracket. So we have this first x squared, and then when we multiply these brackets, I have another x squared. I have minus 3x minus 3x plus 9, and I know that that is 17. So when I tidy that up then, I have 2x squared minus 6x plus 9 equals 17. In order to solve any quadratic equation, it needs to equal 0. So you are going to need to take away 17 from both sides. So we get 2x squared minus 6x minus 8 equals 0. Every single one of those numbers can be divided by 2, so just make the equation a bit easier for yourself and divide everything through by 2. So you've got x squared minus 3x minus 4 equals 0, and you want to factorise that. It's easy type of factorisation, so you just want to find two numbers that are going to multiply together to give you minus 4, add to give you minus 3. So those two numbers are going to be minus 4 and 1. You do minus 4 times 1, you will get minus 4, and then you do minus 4 plus 1, you will get your minus 3. So easy type factorisation, they go straight into the brackets. So x minus 4, x plus 1 equals 0. And then to find out what x is, you set each bracket equal to 0. So either x minus 4 equals 0, and you get x equals 4, or x plus 1 equals 0, and you get x to be minus 1. Okay, finally then you want to fill that into, and I would always pick the easier equation to find the y value. So we've got y equals x minus 3. So when x is 4, y equals 4 minus 3, which is 1. And then do the same thing for the other one. So if y equals x minus 3, when x is minus 1, y is minus 1 minus 3, which is minus 4. So you will have two pairs of answers for this equation. Just write them on the answer line then. So the two pairs of answers are x equals 4, y equals 1, or x equals minus 1, y equals minus 4. And that's the end then of that paper.